Good morning. I found a very interesting problem that we did not cover in our class yesterday that my Tuesday-Thursday group chose number 23 on page 575. This is a side-side-side case where we have angles A, B, and C that we need, but we are given side A is 3.6, side B is 6.2, and side C is 4.1. So what we're wanting to do is use the law of cosines to find an angle. So we can pick A, B, or C. I'm just going to pick A. So the law of sines would say that A squared equals B squared plus C squared minus 2BC times the cosine of angle A. From yesterday, we solved algebraically in an earlier problem and found that A would be the inverse cosine of B squared plus C squared minus A squared all over 2 times B times C. When we do this, and I have to pull out a calculator, what we want is to find angle A. So I find B squared. So let me write all this in here. B squared is 6.2 squared plus 4.1 squared minus 3.6 squared all over 2 times 6.2 times 4.1. That's what's inside the inverse cosine function. So give me a moment while I type all this into the calculator. I'm doing 6.2 squared plus 4.1 squared minus 3.6 squared. So I get that the numerator up here is 42.29. Then I'm going to divide by the product of 2, 6.2, and 4.1. To get inside this inverse cosine is rounded 0.832. So I take the inverse cosine of all of this and get that angle A is 33.7 degrees. At this point, we can start applying the law of sines using angles A and side A and side B or C. I'm just going to pick B. So the law of sines says that the sine of 33.7 degrees over 3.6 will be the sine of B degrees over 6.2. So B will be the inverse sine of 6.2 sine of 33.7 degrees over 3.6. Typing this into the calculator will give us angle B. So 6.2 times the sine of 33.7 degrees divided by 3.6. Take the inverse sine of all of that. We get that angle B is 72.9 degrees. Finally, to get angle C, we will subtract from 180 degrees the two known angles. So 180 minus 33.7 minus 72.9, and we get that angle C is 73.4 degrees. Now, if we look at this solved triangle, one thing that we noticed in my other class this morning was right here we had a discrepancy. In every triangle, whether it is oblique or right, the largest side will always be opposite the largest angle. The largest side is side B of 6.2, which means angle B must be the largest angle. But angle C here is 73.4 degrees according to our work so far. So why is there a discrepancy? We haven't done any incorrect work per se. What it turns out is that when we apply the law of sines, we have a certain set of ambiguous conditions. I'll go to a new page and write the givens that we used right over here in angle A, and side B. So angle A, side B, 33.7 degrees. A was 3.6 and B was 6.2. From Monday's class, in applying the law of sines, we have to check for the ambiguous case. The ambiguous case will possibly occur when the side that's by itself, in this case the 6.2, when that side is larger than the known side that is across from the angle. The lonely side here is the 6.2. It is larger than the 3.6. So we have to check to see whether the lonely side times the sine of 33.7, we need to check to see if that is less than 3.6, which is already less than 6.2. What we're doing is we're checking that altitude to see whether or not the side that is the 3.6 is smaller than or larger than that altitude. If this altitude, 6.2 sine of 33.7 degrees, is larger than A, then we have no triangle, and this is a no solution question over here. If, however, this 6.2 times the sine of 33.7 degrees is smaller, we have the ambiguous two-triangle case. So let's take the sine of 33.7 and multiply it by 6.2. We get that that is 3.44, which is definitely less than. So this is a two-triangle case. So we have two triangles here. Here's triangle 1 and triangle 2. Now in the ambiguous case, the two-triangle case, one of these angles for B is going to be acute and the other is obtuse, and they will be supplementary. What we found over here was that we got a 72.9 degree angle. That belongs to triangle 2. Because we now know that this is an ambiguous case when applying the law of sines, and we've also learned that we actually cannot have 72.9 degree angle for angle B in this triangle, that triangle 2 is not the triangle that we are actually solving. We are solving triangle 1, which means this 72.9 degrees is useful to us. We actually need its complement. We need the complement of 72.9 degrees, which is 107.1 degrees. So we can go back to this earlier page, and I'm going to do some very careful erasing here. Instead of the 72.9, we're going to have 107.1. then in that case, angle C is 180 degrees minus 33.7 degrees minus 107.1. So 180 minus 33.7 minus 107.1 gives us angle C of 39.2 degrees. Now if we check to make sure that the largest angle is opposite the largest or longest side, and we do have a correct triangle now. The largest side is 6.2, that's B, and angle B is the largest. Side A is the smallest side, and angle A is the smallest angle. Side and angle C happen to be in the middle. So this is one way we can deal with a side-side-side triangle that ends up, when applying law of sines, to be the ambiguous case. If you don't want to use the ambiguous case, we actually don't have to. If I go back to the original givens, after we've solved for angle A, we had that angle A was 33.7 degrees, side A was 3.6, B was 6.2, C was 4.1. Let me double check, make sure I got it right. Yep. We can actually solve for either angles B or C using the law of cosines a second time. So if we did that for angle B, that would be that angle B would be the inverse cosine of A squared plus C squared minus B squared over 2 times A times C. Inverse cosine of all that will give us the correct B. So 3.6 squared plus 4.1 squared minus 6.2 squared, then divide by the product of 2, 3.6, and 4.1. Then we take the inverse cosine of that, and I'm going to add a couple extra decimal points here, 107.08 degrees, which rounded to the 10th place, 107.1 degrees. That's exactly the angle for B that we got when we took the complement of the original B that we found using law of sines. This ended up being an ambiguous case when we applied the law of sines. If you don't want to have to worry about using the ambiguous case ever, you can absolutely use law of cosines to get the second angle. When you do that, you are guaranteed to get the correct angle, and then subtracting 107.1 and 33.7 from 180 will get us the 39.2 degrees for C. So in summary, when we have a side-side-side problem, side-side-side was these original three sides. If you want to guarantee that you have the correct angle after you've applied the law of cosines once, you can apply the law of cosines a second time, and you would not have to worry about the ambiguous case. If you don't mind worrying about the ambiguous case, what you have to do is go through, find all three angles, and verify that we have the correct longest side across from the largest angle.